Hello everyone, good morning. I'm Kashi, research coordinator of this project. Our project is about life cycle assessment of battery operated electric vehicles and hybrid vehicles.
Hi, my name is Nathida Japju. I am a data collection specialist of the project.
Hello everyone, myself Parak, and I was responsible for doing uncertainty analysis in this LCA.
And my name is Sarah Hershey. I am the project management lead for our LCA research group. This first slide here outlines the key parts of our study we will be presenting to you today.
We will begin with the goal and scope. The electric vehicle is emerging among car users in the US. The electric vehicle is expected to have less potential for an environmental impact and greenhouse gas emissions. This motivates us to study and compare the environmental impacts of two electric vehicle types, which are BEV and HEV. So the goal of the study is to conduct an attributional life cycle analysis from cradle to wheel of Tesla Model 3 and Toyota Prius 2022 and compare the environmental impacts. The audience of the study are auto manufacturer, regulator, policymaker, and customer. Next section, Sarah will discuss the system boundary of the study.
Thank you, Natita. We're going to move into a more detailed discussion of how we modeled our study. To develop a thorough understanding of the life cycle of both a BEV and an HEV, we began by defining the system boundary. We chose to develop a combined system boundary in order to highlight the stages in which there are overlaps and divergences in the life cycles of the two vehicles. The green boxes are related to stages and flows relevant to both vehicles. For example, each vehicle is constructed from metals and minerals, therefore the mining of these materials is shown in green. The blue and yellow boxes are associated with stages and flows specific to a BEV and an HEV, respectively. Finally, the pollution and waste outputs are shown in gray. Material flows from one stage to the next are denoted by a solid line arrow or a dotted line arrow. Dotted flow lines are marked as such simply to clarify that the flow line does not interfere or combine with a flow line that it intersects. For example, the transport of materials from the mineral and metal refineries is related only to the production of the hybrid vehicle's nickel metal hydride battery, and not to the production of the glider. The gray dashed line symbolizes a phase border. For this study, we focused on the production and operation phases. The separate phase boundaries contain the stages associated with each phase while also allowing us to clearly illustrate which phase produces the outputs of interest. Lastly, the system boundary is designated with a dashed red line. From this diagram, you can see that the life cycle of both an HEV and a BEV follow the general pathway from material extraction to refining, to component development, to vehicle assemblage, to the passenger operation phase, and ending at disposal and/or recycling. Important omissions to our boundary include the construction of all refineries and production plants, the assemblage of all components to create the final vehicle, disposal and/or recycling of the vehicle, tire emissions, and human labor. Next, Parag will discuss the function and functional unit for our study in detail.
Thank you, Sarah. Let's understand the function and functional unit of this LCA. Function of this product here is a passenger transportation. On that basis, we have defined our functional unit as a 1 mile traveled by a vehicle with a one occupant. Rationale for choosing this unit are: first, it is chosen because it closely aligns with the real-world usage pattern. Second, it is consistent and standardized measure. Third, it also acknowledges the importance of considering occupancy rate. And next, Natita will take on to the impact analysis after the LCA.
The impact assessment is characterized by Tracy 2.1. The impact category that we calculate are acidification, potential, ecotoxicity, eutrophication, global warming potential, human health particulate, human toxicity, and smoke formation potential. According to the result, the BEV has a higher impact on most categories in the production phase. HEV has a higher impact on every category in the operation phase. However, when the impacts of the production phase and the operation phase are combined together, we found that HEV has a higher impact on acidification potential, ecotoxicity, global warming potential, and smoke formation potential. And BEV has a higher impact on eutrophication, human health particulate, and human toxicity. Next section, Parag will discuss the uncertainty of the study.
Thank you. Now I want to highlight various uncertainties related to the analysis that will affect our impact analysis. First, in uncertainty in electricity mix. So there are various factors like weather and fuel cost contribute to the unpredictability of the carbon intensity. Percentage used of various resources in electricity mix fluctuate overall environmental footprints. Second, battery efficiency. Battery efficiency have a higher impact onto this analysis. As an example, higher the efficiency, the lower the impact, and vice versa. Third, battery chemistry. Various materials are used during production of these batteries. Due to that, it adds uncertainty into the impact analysis. As an example, solid-state batteries have less toxic material compared to lithium-ion batteries, which means that solid-state batteries are 39% lower impactful onto the environment. Fourth, battery degradation. So after several period of usage, battery loses its capacity to store the energy, and due to that, the efficiency of the battery will reduce over the time, and that adds uncertainty onto the efficiency and charging frequency of the EV vehicle. Next, we will see the uncertainty into the electric energy mix. Environmental impact of BEV depends on electricity mix. As we discussed here, graph, it shows how the percentage of the resources usage change into the electricity mix. This graph is based on 2022 data, and here you can compare coal, natural gas, solar, nuclear, and wind energy percentage and how it changes over the year and like each and every month. Most carbon intensive months here are winter months, and least carbon intensive months here are summer months, spring, and fall months. Next, I'll explain the uncertainty in a solar power generation. So we have taken solar power as an example to show how uncertainty of electricity mix affect our overall impact. For that, we have taken a 2022 data of the solar power generation for each month, and based on that, we have performed Monte Carlo simulation for uncertainty. Here, our confidence level that we choose is 95%, and this it is a standard measure that enhances credibility of our findings. Simulation give maximum and minimum values of associated with the uncertainties. Here you can see that the minimum value that we got is 13,650 megawatt hour, and the maximum value is 19,950 megawatt hour. So this is the range that we got for uncertainty after doing the Monte Carlo simulation. Next, Mohammed will take on to the key findings.
Thank you, Parag. So here is the individual impact categories for the production and operation phases for BEVs and HEVs. So for acidification and ecotoxicity, we can see the overall HEV has more impact than the BEVs. for the if we see about the production and the operation, in the production phase, EV cause more acidification and ecotoxicity potential comparative to HEV, whereas HEV cause more in operation phases. Moving to the next slide, where if we see the global warming in with biogenic and without biogenic, the overall global warming potential for the HEVs is higher than the EVs, and the same trend for the production and the operation phase being observed as like the acidification. When we move to the next slide about human toxicity, either cancer or non-cancer, here the trend is little bit different, where EV cause more human toxicity potential than the HEV, but the EV cause more in production phase rather than the operation phase. When in the next slide, the smoke formation, the trend is quite similar, where HEV has overall more smoke formation than EVs, but the production and operation phase are quite different. In case of HEV, the operation cause more smoke formation potential, whereas in production phase, the EV cause more smoke potential. For the comparative analysis, Sarah will explain it.
Thank you, Mohammed. As we observed in the previous slides, the BEV performs better in some impact categories, while the HEV performs better in other impact categories. In order to take a closer look at these outcomes, we conducted a comparative analysis under two different scenarios. The first scenario depicted in this slide answers the question, if I purchase a new BEV instead of purchasing a new HEV, what will be the % reduction of each environmental impact? The blue and green bars represent the production and operation phases respectively, while the yellow bar represents the total % reduction. For example, if we purchase a BEV rather than an HEV, we can anticipate 100% less acidification potential during the operation phase of the vehicle. Furthermore, this tells us that a BEV does not contribute any acidification potential during this phase. In general, we observe that the BEV provides significant reduction in all impact categories during the operation phase compared to an HEV. Additionally, we see that the choice of a BEV over an HEV would result in overall reduction in 5 of the categories. On the next slide, we take a look at the second scenario, which answers the question, if I purchase a new HEV instead of purchasing a new BEV, what will be the % reduction of each environmental impact? In general, the results show that the HEV provides reduction in most impact categories during the production phase compared to a BEV. Finally, we observe that the choice of an HEV over a BEV would result in overall reduction in 4 of the categories.
After going through all the results, we come up with the following key takeaways. BEVs demonstrate lower overall impact in operation phase, whereas HEVs demonstrate lower impact in most of the production phases. So the electricity mix is also a key component that define the BEV's viability. And if we conclusively decide the BEVs has less environmental impact comparative to HEVs. If you have any question, we are open to answer the question.